Welcome to BKW Physics. I'm Mr. McConley, and today I have a demonstration where I have two spheres. They're both black rubber, and they're very different though. Very, very different. They kind of feel the same. You squeeze them, you don't really notice anything. Their mass is as far as I can tell. I mean, we'd have to put them on a balance, but they feel like identical mass. One looks a little duller than the other, maybe, but not much. But watch what happens when I drop these. Okay? Watch that again. This ball is about the saddest bouncing ball I've ever seen in my life. Okay? It's purposely made that way, by the way. Whereas this one bounces like you would think a normal rubber ball should bounce. Now they're actually called happy and unhappy ball. Okay, I think you can guess which is which. It makes me a little unhappy when my ball bounces like that. So, how can this possibly be, and how does this relate to physics? Well, both of them have the same potential energy at the top. Both will have the same kinetic energy right before they hit the table. I did the same amount of work to lift them to the same height, assuming they're the same mass. All clear on that? When I drop it, and they hit the table, there's an energy conversion, right? You go from going this direction, you elastically compress the ball. Remember elastic potential energy? So this one, it elastically compresses, and then it elastically springs up, and all that energy is converted into the opposite direction. So you got kinetic, elastic potential, kinetic again. Now you lose a little bit. Why are you losing some of the energy? Because listen, it makes a noise. If it makes a noise, noise is a form of friction. It's a form of Q type of energy. And so you are, quote, losing some energy. It's not being lost, it's just going to another form. So if you had 100 right before you hit the table of energy, you hit the table, and when it bounces off, you might only have 80 because you lost 20 of it to the Q. Well, what's going on with this one then? This one is not elastic. Okay, it's not, I mean, it has a little bit of elasticity, but not much. You know, it just doesn't bounce well. So it's non-elastic. So you'll notice also, listen to the noise. Hear how much louder it is? You might not be able to hear it on the video, but you can hear in the classroom that this is a much louder noise because it is dissipating a lot more energy when it hits the table. Now, that also brings me to the idea of there are elastic and inelastic collisions, correct? Elastic collisions is when the energy is mostly transferred. So this one, most of the energy is transferred and it bounces off. This one, most of the energy is converted to a different form. Okay, converted to a different form. And this ball will probably heat up also because it's probably producing quite a bit of heat when it splats like that and makes that noise. So it'll probably heat up if I kept throwing it on the table. So for today, physics.